Good afternoon. My name is Aisha, and we're going to be interviewing you on your paper today recently about your remote sensing in mangrove forests. Could you please introduce yourselves?
Yeah, my name is Kasper Johansen. I work as a senior research scientist here at KAUST, specifically focusing on remote sensing of different environments, so not just coastal areas, also rangeland areas, agricultural areas, and many other environments, such as even urban environments.
Oh, that's very interesting. And
Yep. So my name is Javier Blanco. I work in the same group that Casper does. I'm working as a postdoc. Well, basically, my background is quite similar to Casper, and I have been focusing the last 2 years or something like that, in mangrove forest and, well, in dryland environments in general. And Saudi is quite dry,
so working in mangrove forests, obviously, you explore a lot of different environments. What do you find to be most interesting or intriguing about this kind of field of research and looking into these kind of things?
Oh, I personally really like remote sensing because you get to explore all sorts of environments.
Yeah.
So remote sensing is obviously about observing the environment remotely. So you can use drones, for example, but you can also use satellite images to look at much larger areas at the country scale or even global scales. So you can really get an appreciation about what the world looks like, and you can zoom into different environments, start analyzing those, monitoring, seeing how they change over time. So that's what I find really interesting. So it's not just a very narrow field, you get to see lots of parts of the world.
Oh yeah, you get to explore many different types.
Yes.
Javier?
Yeah, so basically that's it. Like, instead of being in the field, and because when you are on the ground, you are only quite limited to what you can see. But if you go above, you fly high with drones, satellites, you can get a very bigger picture of everything, and well, that's quite powerful.
If it was a news headline, how would you explain what remote sensing is?
Well, remote sensing is all about collecting information and images from a distance. So it can be anything from just using a handheld camera or your mobile phone and taking a photo, to using satellite images that, like satellites, they are often located 500, maybe 600 kilometers above the surface of the Earth, looking down on Earth and taking photos. So that's often what you refer to if you're talking about remote sensing. It's using satellite images, or it can be airplanes, or it can be drones as well.
So that's a very high height. Javier?
So yeah, for me, if I had to give just one simple sentence, it would be that remote sensing is like having eyes in the sky. And obviously it depends on how complex those are, but you can see different things, and that's it.
So how can remote sensing be used in environments other than mangrove forests?
Yeah, it can be used for a lot of different purposes. So, for example, for illegal clearing of the Amazon rainforest, you can, if there's any natural disasters, you can obviously look at images before and after. You can see where the damage is done, so you can send people in to help, for example, with rescue operations. So there's lots of different applications.
There are so many applications out, and I think that now with artificial intelligence, machine learning, the number of applications that you can get from remote sensing is exploding. But for example, you can see, lights from the sky in the night, and then you can use that information to understand where people are, for example.
And even in urban areas, they often heat up much more than the surrounding areas. So you can look at urban heat island effects, they're called. So you can use thermal cameras from satellites to detect where's the temperature really high in urban areas. And that could be an area you might want to start planting more trees in, or have green rooftops to reduce the temperature and the livability of those areas in the urban areas.
How does measuring water usage and obtaining information from drones help precision agriculture?
Well, it's obviously very important to know how much water is actually being used, especially in Saudi Arabia, where approximately 85 to 90% of all water goes towards agriculture. So you want to really save on water, because most of the water is coming from aquifers, and it's non-renewable water. So once you run out, you're out of water. So that's obviously a big problem. So you want to reduce the usage of water as much as possible. So by looking at what crops they're growing, you can determine, is that a crop that consumes a lot of water, or is it one that doesn't consume as much water? So ideally, you don't want to use as much water. You can also use it for compliance, for example, to see, are the farmers actually growing what they're supposed to? Or are they growing crops, for example, like alfalfa, that's using way too much water? So you can really get a clear picture about how much water is being used, not just for the whole of Saudi Arabia, but for individual fields. So with remote sensing, drones or satellites, you can zoom into individual fields, see how much water they're consuming every year, and you can get an estimate about how much it is. And I guess you can't really manage anything you can't measure. So it's important to measure how much water is being used, so you can, yes, basically have as much information as possible to save on water and reduce that water usage.
So it helps keeping things in track of like water usage to make sure that Saudi Arabia can continue living with the limited access water that we have.
Yeah, exactly,
Okay.
yeah.
What other technologies can be used to further advance SDG 15?
So SDG 15 is life on land, right? So we want to monitor and to understand how our terrestrial ecosystems, how healthy those are. So actually whatever that you can think about, from sensors in the field, also help us not just to remote sensing, but to understand what is going on. So just think about anything, basically. Just go to the field and water technologies, so anything, basically.
Yeah, biodiversity, for example. Biodiversity is obviously very important. So, it's important to measure the health of ecosystems. And you can do that with remote sensing, and you can track it over time. You can collect images every day or maybe every month, every year, and you can see how do things change. Do they change for the better or for the worse?
Okay.
And then you can use that information to manage those environments.
Okay, so again, like question 5, it's to make sure everything's in track and to,
Yeah, it's basically and remote sensing is basically a tool you can use to monitor what's going on. And if you have any initiatives, for example, to restore vegetation, you can then monitor, is it actually working? Because one thing is planting a lot of trees, but it's no good if they're going to all die after a couple of years, for example. So by monitoring large areas, you can see how are they tracking, are they performing as they should based on the management efforts that's put into that environment.
okay. And that's crucial for many countries to make sure everything's in track and that they're doing everything sustainably and...
Exactly, yeah. So you can't manage what you can't measure. So
Okay.
by measuring the environments, or you can make wise and informed management decisions. That's right. That can be
Okay.
sustainable and good for the long-term environment.
Your paper talks about SDG 15,
Yep.
life on land. But I was also wondering if it's relevant to other SDGs, like SDG 14, life below water.
Yep. So yeah, I mean, first of all, I think that every ecosystem in the planet is interconnected, so we should approach it holistically, right? Everything is connected on the earth. But anyway, more focus on the stuff that we do, like mangroves. What is happening on the coastlines will for sure affect what is happening below water. But of course, and then the stuff that we are using remote sensing, we can not, if it's too deep, but for example, seagrasses, we can monitor those environments. But it's interconnected.
Okay,
Isn't it?
so why did you choose SDG 15 over SDG 14?
Why? That's a very good question. But I guess that because from my background and my experience, I've been focused on land ecosystems, and they are quite easier to monitor using remote sensing. So just not to complicate my life too much, I guess.
Yeah.
But to have fun at the same time.
Yeah, it is actually quite difficult to measure aquatic habitats.
Yeah.
Because
okay.
when you measure things on land, well, you have the atmosphere. There might be a bit of dust in the atmosphere which can affect your satellite images. But if you measure coral reefs or seagrass underneath the water, you basically have a whole other atmosphere you need to correct those images for.
Yeah.
It can be really turbid water, for example. You have different light interactions underwater. You have different depths. So something that's at 1 meter depth as opposed to 5 meter depth looks completely different because there's much more light coming down to 1 meter
Yeah.
depth as opposed to 5 meter depth. So it's actually a lot more complicated to map anything underwater. But you certainly can.
So it's easier on land than water.
It is easier, yeah.
Not as complex.
Yeah. Okay.
Yeah, but it's also very important to measure aquatic habitats. And there's a lot of remote sensing going on in that area for sure. Our group is mainly just focusing on terrestrial environments, on land.
Thank you for your intricate answers. And as a closing question, I will ask you, so what is your advice for people who are new and who want to explore more about this field of research of, yes.
Well, I guess when you use remote sensing, you can really use it for any part of the Earth. So any type of environment you're interested in. So if you were to select remote sensing as your research area, I would recommend that people choose maybe an area of their particular interest. It could be rainforest, it could be deserts, it could be rivers, it could be urban areas. So you can kind of narrow in on what you might be interested in, and you can use remote sensing to map and monitor those environments and inform some of the decision making. For example, if you're interested in urban areas or urban planning, well, it's important to map the urban areas so you can actually see what's going on, where the streets are, and how you can do proper urban planning. So there's so many different applications. So I guess it's a great research area to get into because you can focus on what you're interested in, but you might also branch into other areas you become interested in later on.
All right, nice. And could these technologies be used in other fields, such as finding animals in like very like shrubbed areas with a lot of like in rainforests or other areas that are like packed with different life?
Yeah, for sure. I mean, there's a lot of, the cool thing of remote sensing is that it's a tool. So as with any tool, you can use it for a lot of stuff. And one of those applications is animal tracking and ecology, movement ecology. And there are actually very cool things that people are doing. For example, understanding how elephants are moving in the savannas and or in other complex forests, not maybe elephants, but other type of animals. And they use remote sensing again as a tool to understand what's the impact of elephants in this case or other animals on vegetation, because that's what you can actually see from the sky. So yeah, of course you can.
Yes.
But don't forget, remote sensing, it also depends on the spatial resolution of your images. So if you zoom into a photo you're taking, it starts becoming pixelated. And it's exactly the same with satellite images. So maybe an elephant is probably a good example because it's big, so you can actually see elephants from satellite images. But if you're talking about individual flies or little bugs, you can't see those from remote sensing. So you might need to use indicators of how many that's available in that environment. So you might look at, for example, plant composition and then make some conclusion that if there are certain types of plants, then maybe you're more likely to find these bugs you're looking for. You can't actually see bugs from remote sensing because they're just too small. Generally, from satellite images, the smallest pixel you'll get that you can work with commercially is around 25 centimeters. So we're talking about like an area like this here.
Yes.
So you need something that's a lot bigger than that before you can actually start identifying what that is.
And could this technology be used in like search and rescue operations? For example, people trapped in avalanches or other areas?
Absolutely, yeah. Especially drones. They are obviously very versatile. They can be flown whenever. With a lot of satellite images, if you have cloud cover, you can't necessarily see through that cloud cover.
Yes.
And they probably don't have quite the right resolution. But with drones, they're obviously very versatile. They can be flown whenever. And even if there are clouds above, they don't affect you flying drones below. So drones are very suitable for search and rescue, that's for sure. And they have the right resolution as well, so you can potentially look at identifying people.
Yes. All right, thank you.
Thanks
You're welcome.